All right, so we did one of these yesterday. We're just going to, or the other day, we're just going to keep going with it. I'll show you again. So step one, getting your radical by itself. So whenever you're solving an equation with a radical, even if there's two radicals, you want to isolate at least one radical, right? You got to get it by itself, right? You isolate and then attack. The ninja way. 2x plus 3. All right, so then we got x is equal to the square root of 2x plus 3. All right. Now, the idea is to get rid of the square root. Before we can solve for x, right, if I have x equals something and it's also defined in x, then it still doesn't make any sense. Like if I told you to, define a word, let's just say, hey, what does the word redundant mean? And you said, redundant means to be redundant. Then that doesn't tell me anything about redundancy, right? X can't equal something with x in it, or else it doesn't mean anything about x. I don't know what x is still. So I got to get x all by itself. That means I got to get the square root gone. So I got to square both sides. That's the opposite of a square root. It's the square. Now, remember we talked about this. If you square both sides, then that opens the door. So I'm going to just say opens the door to extraneous solutions. So anytime you raise both sides to an even power, in this case it's 2, right? But if I raised it to the 4th power, or to the 6th power, or to the 8th power, or any even power, it opens the door to extraneous solutions. So then I have x squared equals the square, and the square root cancel out, and I got 2x plus 3. All right, I see that this is quadratic, because there is an x squared term. So when I see quadratics, I need to set them equal to 0, especially when it's 3 terms, set them equal to 0. So x squared, that means I'm subtracting 2x from both sides. So minus 2x. And then I'm subtracting 3 from both sides. Minus 3 equals 0. And since I have 3 terms, right, there's different techniques for solving quadratics. If you have 3 terms, then the first thing I would say is try to factor it. Not greatest common factor, but, this, I call it full factoring, but it's just a type of factoring for 3 terms. So that's when I say, okay, x times x is x squared. Then I'm looking for 2 numbers that I can multiply together to get negative 3. But when I add those numbers together, I get negative 2. What are those numbers? Negative 3, positive 1, right? So now I got my factors. I know they check out because negative 3 times 1 is negative 3. And negative 3 plus 1 is negative 2. So that checks off. Now I set each factor equal to 0. So x minus 3 equals 0. X plus 1 equals 0. That means x is equal to 3. And x is equal to negative 1. Now, we got our answers. But you don't know if it's your real answer because there could be false solutions. Remember, extraneous solutions, that means there's false solutions. Right? That's what an extraneous solution is. So we have to check to see if these are false solutions. How you can do that is you can just plug them back into the original equation. So I'm going to do it in the calculator this time just to show you how easy it is and get you using your calculator as a tool to help you rather than as a crutch, right? It can be a tool or it can be a crutch. And the crutch is all fine and well while your leg's broken, but once your legs heal, you're still using a crutch. That means that's just making your legs weak. And you ain't going to be able to survive in this world all week. And because this is the jungle out here. We in the math game. This is the jungle, all right? You can't be, it's survival of the fittest out here. All right, so we got 3 subtract the square root, right? So I'm going to hit second, and then I'm going to hit this x squared right here. Gives me the square root. and then I got 2, and then I'm entering in 3, because I'm checking for 3, right? Plus 3. Is that equal to 0? Yep. So I know that was a solution. Now I do the same thing again. You can scroll up and catch that. Bring it down. Changing this to, all right. So here's something that you might want to know. So if I put a -1 in here, it's going to start erasing stuff. Here's what I can do. I can hit the second, and then where you have delete, it says insert. That lets me insert numbers before wherever my cursor is. And I just want the -1, subtract. All right, I want a second, insert. That makes things a little faster to me. So, and then 1. So I got my -1 in there. Hey, that says -2. That means that's not a solution. Now, that tells me if that's not a solution, this is a false solution, which is called extraneous. So, we have the real solution, and then we have the false solution, right? The fake, right? Any questions on this? All right, so when you're doing this, you're solving with a radical, right? We can go back to the rules. First, you got to isolate the radical. You got to get the radical by itself. Then you got to raise each side to whatever the power is for like the root. If it's a cube root, you got to raise it to the 3rd power. If it's a 4th root, you raise it to the 4th power. You do the opposite of the radical to get rid of it. And then you just got to solve, Sometimes you might have 2 radicals. Let's do this one. We got double radicals. When we got 2 radicals, we got to get one of them by itself. All right? So, it doesn't really matter which one you get by yourself, but I would say you want to get the more complicated one by itself. Also, I just don't really like messing with the negative, so I'm going to say plus the square root of x plus 1 on both sides, plus the square root of x plus 1. And then that means this one cancels out, and I have the square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. All right, taking good notes. This is key, y'all. This is key. Your notes are the main thing. If you're like, some people take the sloppiest, garbagest notes, and then they're like, I don't get this class. Well, your notes are not good. So how are you going to learn? Because this, you can listen in class, but it's not all going to stay there, right? You got to go back and solidify things with your notes. All right, I got one radical by itself. So now I need to raise things to the power to get rid of that radical. So I need to raise this to the 2nd power. And now notice, right? When I raise to the power, I got to raise both sides. I'm not doing individual terms. You got to raise both sides, right? Sides to 2nd power. Not individual terms, but sides, right? So when I do that, what does that mean when I raise both sides to an even power? Well, the square root does go away, but what does that mean for my problem, like overall? What's an idea that's going to open up for? You can do that too. Like, you're not wrong on anything. I guess what I'm fishing for is that whenever you raise both sides to an even power, right, then you got to remember to check your solutions because you could have extraneous solutions. So I'm going to write that extraneous solutions, right? Right? It's possible. Maybe I should say possible. Possible extraneous solutions because I raised both things to an even power. So then, yes, the square root and the square cancels out on one side, and I got 2x plus 3. Now, this side over here, that's not how it works. Like, a lot of people are going to be like, oh, that's just 1 squared plus x plus 1. But no, because when something is squared, it means you take both sides and or you take it and you multiply it by itself, right? That's the reason it cancels out over here, because the square root times the square root makes the square root go away. But over here, this means x plus, or 1 plus x plus 1 times 1 plus the square root of x plus 1. Now, this is the reason I taught you box method. Stuff like this more complicated, right? If you can still use full, I don't really care what you use, like I've been saying, but box method comes in a little bit handy here. And this is why, because it helps you to keep things nice and neat. So if I'm multiplying these, I say 1 plus the square root of x plus 1, right? 1 plus the square root of x plus 1. And then I create my box. And now when I'm filling in my box, 1 times 1 is 1. 1 times the square root of x plus 1 is the square root of x plus 1. Same thing again, 1, that's x plus 1. And then the square root of x plus 1 times the square root of x plus 1 is x plus 1. All right, now I'm just combining my like terms here. I'm simplifying this, right? This side over here just keeps coming down, and I got 2x plus 3 equals, what does it equal? Well, let's think about this. These two can combine, and I can say this is an x plus 2. Right? And then over here, these two can combine. And if I add a square root to a square root, then I got 2 of those square roots, right? So plus 2 square root of x plus 1. Right? Because it's like a unit. It's like inches or something. If I add 1 inch to another inch, I got 2 inches. Right? But people always make that complicated. It's not as complicated as it may seem. It looks complicated, but it's not that complicated. Or, with the right mindset, it doesn't have to be. All right, so here's where I'm at now. Now, I still have a square root in my equation, and I still need to get it by itself so I can make it go away. So I do this again. I isolate. So I subtract x, right? I subtract 2 from both sides, subtract 2. That gives me x plus 1 equals 2 square root of x plus 1. All right, I want to get that square root by itself. So I can divide by 2. So then you could say, 1/2 x plus 1/2 if you wanted to. I'm just going to leave it like this. There's other ways you could write it. I'm just going to leave it like that. And then that equals the square root of x plus 1. All right. Y'all with me? Anybody confused about anything? If you don't speak it, I ain't going to know it. If you say what you're confused about, I can probably help you through it. All right, I'm going to keep rolling. So, we want to get rid of this square root. So I got a square. What I do to one side, I do to the other side. The square cancels out over here, and I just got x plus 1. But now over on the left-hand side, it's not just canceling out. It's not just x plus 1. Let's look at it. Now, if I have a numerator square, then, that's x plus 1 squared, because this is a binomial. But in the denominator, well, what's 2 squared? 4. So it's still just 4. All right, x plus 1 squared, let's do that over here. That's x plus 1 times x plus 1. Now, when it looks like this, normally I'm not going to use box method, because I feel like box method's best for more complicated things. And if I'm just using this, maybe I use full method. I don't know if y'all are familiar with this. I'll show you this. It only works when you're multiplying binomials, meaning one term with 2 terms times another with 2 terms, right? So it says FOIL stands for first. You multiply the first terms together. That's x and x. right? So that's x squared. Then this means the outer, right? That's x times 1. So that's 1x. And then the inner, right? That's 1 times x. So plus x. And then the last, that's 1 times 1, which is 1. Now I can kind of combine that a little bit, simplify it further, and I got x squared plus 2x plus 1. It's still divided by 4, and it still equals x plus 1. All right. We're almost there, but we ain't there yet, but we're getting there. Now, the 4. I don't really want to deal with the 4 as a fraction, right? How can I make that fraction go away? Alyssa, what do you say? Come on now, you got this. You can do it. If there's a 4 in the denominator, what do you do to make it go away? We got to do opposites. Right? Anybody? Multiply. We got to multiply by 4. What we do to one side, we do to the other side. The 4 cancels out, and I have x squared plus 2x plus 1 equals 4 times x plus 1. This is a long one. We multiply the 4, we distribute the 4, we got 4x plus 4 equals x squared plus 2x plus 1. And then now we're finally to the point of A, it's quadratic. This is quadratic. Right? So we had to do things twice. For this one, this is a long problem because we had to do things twice. Rest assured, when I give you a test, I feel like this is a harder problem. Now, although we're in the game, we're going to do this problem. And you might see a problem like this on your homework. Would I put something like this on your test? Nah. Because I feel like this is it's on the more difficult side. Right? It's good for you to see it and to know how to deal with it. But when I put your test grade on this and say, like, if you don't understand this, then you don't understand the stuff in this class. Nah. I think this is kind of on the more extreme. Your test will be no extremes, right? I might put one that's a little harder on your test or one that's a little easier on your test. But for the main part, your test is going to be in the middle, right? It's going to be like, Mama Bear's porridge, right? It ain't going to be Baby Bear and it ain't going to be Papa Bear, but you're going to be getting that Mama's Bear. So just think about that. I know this can be a little bit, just mess with your mind some, make you be like, oh, God, this is going to be tough. That don't mean it's going to be easy, but don't worry about something like this on your test. All right, moving everything to one side, I got x squared minus 2x minus 3 equals 0. Finally, to the end, then we're factoring, right? Because we got quadratic. It's 3 terms. We're factoring like this. I got x and x. And then it's the same terms as, it's minus 2x minus 3. That's going to be negative 3 and a positive 1. So x is equal to 3 and x is equal to negative 1. Y'all see how that happened? Anybody I know you might have, there's a lot of, everybody's got, what's
you
up?
went from x minus 2x to...
He factored it.
Oh. Okay, that makes more sense then. Never mind.
All right. I appreciate you, trying to ask about it. If you feel like you don't know something, please do ask. Sometimes I slow down, sometimes I speed up, depending on, when we already did this part, I didn't put so much emphasis on it again. But we're still to the point where we need to check our answers, right? Because this could be an extraneous solution. So let's go back to the beginning. And let's plug one of these in and see if it's going to equal 1, right? So we'll start with 3. And we'll say, all right, square root symbol, so that's second. X squared gives you the square root symbol. And I'm saying 2 times 3 plus 3, right? Out of the square root, subtract the square root of 3 plus 1, right? And now it should, if it's true, it should equal 1. Let's see. Yep. So that tells me that first solution was good. Now I go to my second one, which was negative 1. Enter this. Everywhere there's a 3, I'm putting a negative 1. I'm going to do the insert. Second, the delete button lets you insert, right? And then you can say 1 there. Second, insert, negative, right? If you put a subtraction sign instead of a negative, it's going to say error. Hey, that one's a 1, 2, so that means both of our answers are good to go. So there was no extraneous solutions. So both of these check out, right? Good, come on. So, like I said, if you felt like this one was a little too much, don't get discouraged. You know, it was a little too much in my opinion, but we started it and, you know, I wasn't sure if it was going to be too crazy. Now you've seen it, and when you see it on homework, you can do it without fear, hopefully. It ain't going to be the end of the world. This one, I don't think this one would be as bad, but I ain't too much worried about that. Let me go on to the next. All right. Solving an equation containing a radical, but this one's a cube root. All right. When we're doing this, we got radicals. We got double radicals, right? So not every problem with double radicals is going to be extremely difficult. Some problems are going to be pretty straightforward. You don't know it till you get into it, right? So we still start with the same process. First step is to get your radical by itself. So, I mean, since there's only there's two radicals and nothing else, then that just means separate them. So I'm going to say plus, the cube root of x plus the cube root of x. So then I have the cube root of 4x squared minus 4x plus 1 is equal to the cube root of x. All right. Now we got to think, right? Don't be an autopilot. Be thinking about this. I need that radical to go away. It's the third root. So what power do I need to bring it to make it go away? The third power, right? The roots and the powers are opposites of one another. And, math is about holding balance. So when something's being done, you got to undo it, right? I don't know, yin and yang. I mean, there's a lot of things in the world about this. So the opposite of a cube root is a cube power, right? Third root, third power. The opposite of multiplying is division. The opposite of adding is subtracting, right? Math is a lot about opposites, so you got to wrap your mind about opposites. So third, I'm raising it to the third power. Now, I raised it to the third power. Roman, does this open the door to extraneous solutions? Yes. Why do you say yes?
Eliminate each other.
Well, they do eliminate each other, just like that. All these eliminate each other. But it does not open the door to extraneous solutions. Let me ask someone else. Let's talk to, Keegan. You seem like you want to answer this one?
Yeah. Because it's not even power.
Right, since we raised both sides to an odd power, right? It's odd. It's an odd power. This does not, right? Does not lead, or I'll just say open the door to extraneous solutions. All right, that's something that you need to know. You need to know about these extraneous solutions, right? If you don't know they're there, that's how they're going to get you. Because you're just going to be over there chilling, thinking everything's all good, and then bam, right then and there, you was caught slipping, right? You got to be on guard in the math game. Like I said, it's the jungle out here, bro. You in the jungle and you just minding your own business with your AirPods in, just walking along all dandy, jaguar out of nowhere. What you gonna do now? You dead, bro. You dead. All right. But you on guard? Hey, then that jaguar ain't gonna do nothing. All right. So, because we raised it to the third power, we don't need to worry about extraneous solutions. That means, and I'm probably not going to check my answers because I'm trying to utilize my time wisely. And if I know I'm doing my math correctly, there ain't no need for it. Unless I'm feeling a little shaky about my math, then I probably would still check them. So, it cancels out the radicals on both sides, and we have 4x squared minus 4x plus 1 equals x. All right. Well, this is a quadratic, right? This is quadratic. So I need to get everything on the same side. So I'm saying minus x. I got 4x squared minus 5x plus 1 equals 0. And now I need to factor. And we hadn't factored like this in a little bit. I mean, it's been a while, not too long. So, just in case you don't know. Now, you can use whatever method you want to use to do this. You can use quadratic formula. You can use completing the square. You can use factoring, however you factor. I don't care. If you do it right and you show your work so I understand what you're doing, then I'm going to count it right. Now, if you do it right and it's a mystery how you did it, then it ain't right because you ain't showed me how you did it. So just keep that in mind. But here's the technique I use. Anytime you have a number up here beside your x squared that's not 4, or that's not 1, you just need x squared, 1x squared if you feel like writing a 1, then this is a technique you can use. You can take the 4 and multiply it by the last term. Then you have x squared minus 5x plus 4 equals 0. And then we factor like normal. And we say, all right, I'm looking for two numbers that multiply together to give you 4. That those same two numbers you can add together and get negative 5. Anybody? Negative 4 and negative 1. So x minus 4 and x minus 1, right? Because negative 4 times negative 1, that's positive 4. And negative 4 plus negative 1, that's negative 5. So that checks out, right? Make sure it checks out when you're factoring. So now, because we did this, I'll do it in blue. Because we said this right here, I got to undo that, right? Because that's a little trick you can use to factor. But in math, right, you got to uphold the balance. I can't be multiplying things by 4 unless I'm willing to go back and divide by 4. And since this 4 is how I multiplied the 1 by 4, I got this, and then that 4 is this times this. I gotta divide both of those by 4. So divide by 4, right? Because of this number here that I multiplied by. So now that's x minus 1. And then this is not considered a factor, but I'm going to just leave it in this state. X minus 1/4 equals 0. Now we can say I'll say x minus 1 equals 0. I add 1 to both sides, right? And then I say x equals 1. X minus 1/4 equals 0. When I add 1/4 to both sides, right? I probably will skip this step sometime because it's after we do it a couple times, hopefully you'll be like, yeah, I get it. So now we have x equals 1 and x equals 1/4. Should I check my answers? I'm not going to. Why? Well, time is of the essence. And because I know the door wasn't open to extraneous solutions, and because I'm feeling confident in my math ability, I'm like, if I was on a test, right? Now, if I had extra time on the test, then yeah, I'm going to go back and check it. But in this setting, in a college setting, you don't have infinite time to take a test. I know in high school, I remember, hey, I didn't finish. Can I still take it tomorrow? Sure. But in college, we ain't going to do that because once you don't take it at that point, then the integrity of the test is compromised, right? If I give you a test and you're like, I got to go, but I wasn't finished, well, that's all we can do. You got to stay. And honestly, because we got this online setting and I don't know what's going on, when the 50 minutes is up, that means the test is over. So we got to use our time wisely. That means we can't be checking everything unless we feel questionable about it. All right, moving forward. I'll let y'all try number 71. See if you can do that one. Thing did. Yeah, you got it. All right, so let's go through this. You might be finished. Unfortunately, man, the time constraints, we can only allow for so much time. But Gage, I'm gonna start with you. You seem like you willing to talk about it. Let's see what you got here. Take me through this. Yes, sir. You.
So I put both sides to the power of 4.
All right, to the 4th power.
Yes, sir. And then I simplified 2. After that, I got 32.
32, yep.
And I took the negative 15 with the x on the one side and moved it over with the 32, giving me 47.
Yes, sir.
X equals 47.
Yes, sir. There you go. Now, let me ask you this. Do I need to check my solution here?
Yes.
No or yes?
No, I think it's good.
All right. So, Roman, back to you, bro. Do we need to check that solution?
Yes.
Why?
I believe that two forces equal to 16. You subtract 15 and 16, it is x equals 1.
All right, so I don't know with all that.
2 fours is 16. I mean, not 2 fours. 2 and the 4.
2 to the 4th power is 16.
Yes, sir.
All right.
Am I wrong?
I don't know. Anybody know? 2 to the 4th, 2 times 2.
Yeah, that's 16.
Yeah, that is 16. Nah, you're not. Yeah, that's all right. You got to be checking, Gage. Nah, but that's still not the reason I would say checking it. But that is good to know. 31, yeah. So thank you there. Now that should we check it now? Why?
You got an even power.
Right, since we raised both sides to even, right? An even power. We need to check for extraneous solutions. All right, guys. I don't know if you're like, a lot of learning math is not so much math related. Like, yeah, it's math related, but a lot of learning is related to just the science of learning, right? People are like, I don't learn math well. Well, that's probably because, like, you probably wouldn't learn Spanish well either. I mean, no offense to you, or unless you already know Spanish because you learned it as a child. If you're not learning math so good, I got to ask myself, like, why? Why are you not learning? Is it because your parents weren't good at math? Nah, it ain't got nothing to do with it. Because you've always struggled with math? Nah, because I always struggled with math too. And then, even with that, once I figured out how to learn properly, then I became a math professor. Wow, that's crazy. I went from a I was in the slow classes for math, and why is that? Because somehow I got these powers and I'm abnormal? No. It's because I learned how to learn, right? And here's how you learn. You got to create links on what you're doing. You got to create a link from one thing to another. If you just have information in your head floating around with nothing attached to it, like no reason or rhyme attached to it, then it just floats away. If you have information that's attached to something else, then it stays. And the way to get things attached you got to talk about it, right? This is part of it. It's not just hearing me, it's you talking about it, right? Engaging in conversation. If you just listen to me all day, then you're only going to get about 50% of what's happening. That's, something like that. It's the percentages I might be a little bit off on because it's been a while since I've looked at the studies, but about 50%. And then if you listen and write about it, then you'll get about like 70%. But if you want to get the most, listen, write, and, discuss it or engage in it, depending on how it doesn't necessarily have to be you talking, but you have to be engaging in it, then you're going to get about like 85 to 90%. And then the last 10% is going to be from you practicing on your own, right? But if you're just, listening to me, or you're just writing, and you're not, some people go on the autopilots, then you're not going to be getting that much. That's why I'm going to be asking you questions. And I can't ask everybody questions. It's going to take up all the time. But I want to get you thinking about it. I want to get you involved in it. Because I don't talk to you personally doesn't mean that you can't be involved in the conversation. You can still have the answers and be like, oh, I know this, right? If you kind of sit in that little comfort zone, right? You're in that comfort zone of, oh, he ain't called on me, I ain't worried about it. You ain't going to gain that much. And once you can grab onto this type of learning I'm talking about, that's when you can do anything you want. I'm serious, you can do anything you want to do. You have to figure out how you learn. And everybody's a little different, and everybody learns a little different. But until you figure that out, you're always going to be struggling. And once you figure that out, then, you won't struggle as much. It won't be as hard to you. You'll find that your classes aren't that hard. They just take a lot of work. It's not so much the material that's difficult, it's just the work. So keep that in mind. I'm trying to help you become a better student. I know I needed someone to tell me that, so I don't know if anyone ever did tell me that, but I figured it out eventually. Oh, yeah. So we need to check this. 31 minus 15, yeah, that's 16. The fourth root of 16 is indeed 2. So we're good here. All right. Let's look at some of these. We don't have too much time. Let me see if I got to prioritize anything. All right, so these right here, I'm not going to make you do those. I feel like, although I think they are important, I'm not going to get into that. I might put a question up. This one, I'm not going to get into this one. It's very similar. So there's some of these using a technique called U substitution, which this is the only time you would use it in this class. Then you probably, I can't remember if you even use it in the next class. I think you use it again in calculus. I'm not going to put too much emphasis on this. I might put a couple homework problems with this in there, but all you got to do is watch the video. I think I'll go over it in the video. Instead, I'm going to go to this one, right? Now, here's something that you need to know. So if I have a to the m over n power, right? That's the same thing as the nth root of a to the m power. Or maybe they want to write it like this, the nth root of a, and then this whole thing to the nth power. You can write it either way. But, I guess. Now, why do you need to know that? Well, it helps you to understand how to solve these weird ones. Or not weird, they look a little different. All right, I'm about to delete that. All right, so if I want to solve this one, first I need to rewrite it in a form that makes more sense to me. All right? So I'm going to rewrite it as this is the fifth root of x to the third, and that equals 27. All right? And now I want to solve for x. I want to get x by itself. So I'm going to just work my way from the outside in. First I want to get rid of that fifth root. How do I get rid of the fifth root? The fifth power, right? The fifth power removes the fifth root. So what I do to one side, I do to the other side. Now the fifth root and the fifth power cancel out, and I just have x to the third equals, and now 27 to the fifth, I'm not even going to bother. I'm not going to bother putting that in my calculator and figuring out how big a number that is. I'm going to just do it all at once at the end. All right. So now I need to get x by itself. All right. It says x cubed. How do I get x by itself if I have x cubed? What's the opposite of a cube? A cube root. All right? I feel like that's what you meant. Cube root. Right? So the cube and the cube root cancel each other out, and you just have x. And then that's equal to the cube root of 27 to the fifth. Now, I'm going to just put this in the calculator and see what that gives me. And if it gives me some crazy decimal, I'll have to do it by hand. But it might not. That's what I would do first. So how do we do cube roots in the calculator? If you hit math, then you can scroll down and you see the cube root. And then you say 27 to the fifth power. And then that tells me it's 243. So I'm going to leave it at that. So x is equal to 243. All right, so 5 minutes. Thank you. Question. Do I need to check my answer?
No.
No, you don't, because it was always to an odd power. Now, if you want to check your answer because you're like, I'm not sure if I got this right, well, then you can still do that. I mean, you can always check your answer, obviously, but is it a need? Do I have to do it? No, I don't have to. I guess I don't really have to do anything, but it would be in my best interest to do so. let's try this next one. Same idea, right? This is, I'm going to rewrite it. And these are called rational exponents. Right? Rational exponents are they're just fractions. Rational numbers are fractions, basically. Rational exponents, that's an exponent that's a fraction. I want to put it in radical form, which means that it's going to have that square root symbol. Right? Except in this case, it's going to be a cube root. And this is, x minus 4 squared. And that equals 16. All right. So now I'm working my way from the outside in. I want to get rid of the cube root. If I want to get rid of the cube root, I got to do the opposite, right? Opposite of a cube root is just a cube. So I cube. And what I do to one side, I do to the other. The cube and the cube root cancel out, and I have x minus 4 squared equals, I'm going to just say 16 cubed. Did that open the door to extraneous solutions?
No.
No, it didn't. Thank you. Appreciate it. It did not. So I'm still good there. Now, how do you get rid of a square? You square root, right? You square root both sides. Now, when we do a square root, it's understood to have a 2 right here. You don't have to write it. I'm just writing it so you understand that they're going to cancel out. And you got x minus 4 is equal to. Now, here's something you got to know. Anytime you do a square, anytime you make an even power or an even root, let me say that, you got to put a plus or a minus. So this is plus or minus 16 cubed. So let's write that down real quick. Oh man, we ain't got a lot of time left. I got to write two things, right? So I'll write it over here. So right here. Anytime you take an even root, right? Anytime you take an even root, that opens, I'll say on both sides. Anytime you take an even root on both sides, that opens the door for extraneous solutions. All right, so that's one thing you didn't know. We ain't got enough time to get into everything, but then we got this plus or minus, right? Any time you take an even root, there is a plus or minus. There are a positive version and a negative version. So that's two things that's happening here. So what's my final answer, right? I'm going to say x equals, I'm going to move the 4 over, and I'm going to say 4 plus or minus the square root of 16 cubed. I don't know what that is. I'm sure you can simplify that, but I don't think we got time to do it.